Good morning everybody. We have started oil storage systems. So, in oil storage system we have seen we have to make tank. Okay, tank can be vertical or rectangular also possible. So, if we have vertical tanks, so if we have vertical tank, we have wooden made tank possible, we have metallic, we have non-metallic. So, wooden or metallic. So, in wooden case we have this older tanks, normally smaller older tanks will be wooden, but metallic tank this is newer. And if we say non-metallic, so non-metallic also is being used in the oil field for storing purposes. And whenever you are making sheet, so normally rolled sheet, steel sheets you used. I already told you that gauge is your parameter. So, number of gauge increasing means thickness will be reducing. Okay. So, this is like roller. So, very high pressure, and if you rotate the roller, so this will be this metal will be passing through this one and it will be thinner and thinner every time, one pass, two pass. If you make many times, then it will be thinner and you make desired thickness sheet. Okay. And normally if it is made of iron, and pure iron, like if you are using mild steel, it is very much corrosive. So, you have to see whether steel and different types of steels are there. So, specific type of steel you have to use, so that corrosion will be less but strength will be higher. Now, you got sheet. So, sheet you have to join, right? Then you have to make cylinder. Whole thing cannot be manufactured in your industry or in machine shop, because it is very big, like 400, 170 2 feet, a very large diameter and very large height also there. So, that much of size manufacturing in industry or in machine shop will be difficult. So, you have to, if you are making very large system, then you have to go to field, and there you have to take small sheets and you have to weld one by one and you have to make the system, the whole storage system. And when you are joining, there will be option bolted joint, and there will be riveted joint, okay, and there is welded joint. Okay. So, smaller tanks you can manufacture or you can prepare in machine shop and you can transport. So, if you are manufacturing in machine shop, actually you can test everything, pressure and other thing in machine shop, and you can transport. This is very good for a small shop, but smaller tanks. But if you have very large storage capacity tank, so in that case you cannot manufacture in your machine shop. So, you have to go to field and there you have to construct the system, okay, whole tank. So, because field welded storage tank. Okay. In previous lecture I explained what is bolted joint, what is riveted joint. Now, I will explain about welded joint. You may have seen in machine shops the welding will be there, like two metal I have. Okay. Now, if I want to join these two, then I need one filler material or electrode, filler material or electrode. Okay. Normally filler material will be softer material, so that high pressure, when high temperature, when high voltage is applied, base metal will have, let's say, positive, this is negative, or positivity you are creating, and you create very small gap in between, then spark will be created. So, that spark will create very high amount of heat. When high amount of heat is getting created, the base metal, this is called base metal. So, because these two you want to join. Okay. So, base metal. Okay. So, in base metal will be melted. When both metals are melting, they will get fused together. So, molecular assembling possible. Okay. So, base metal fused together to join this one. So, in welding process, in arc welding, so you are creating electric arc. Okay. Arc. Okay. In arc welding, you need one electrode. Okay. So, if you go to any machine shop, when people are welding, you will see one glass will be wearing, okay, black color glass, and they will be welding. and they will be maintaining small gap, so that spark will be created. If you touch it, then current will be flowing. So, that time there will be no heat generation. Okay. If you create spark will be giving lots of heat, but if you are touching this one, it will not weld, it will not create lots of heat. So, heat is melting the system, then you are fusing together to metal. Okay. So, the welding people, who are the person welding, they will be trained to make the small gap, maybe 2 millimeter gap. Okay. And high voltage is there, because of high voltage spark will be created. So, that spark will generate lots of heat. Okay. Heat will be melting to metals, this base metal. Okay. Then it will be joined, fused together. When it will be solidified, it will be solidified, after temperature will go down, it will be solidified, and it will be unseparable, permanent type of jointing. Okay. And there are different types of welding methods are there. Welding is fusing two metal, base metal must be melted. Okay. One is arc welding, another is gas welding. Okay. In gas welding case, what they do? They will be taking acetylene gas. Okay. Then through one nozzle, high volume, gas will be coming out at very high pressure. Okay. And you give small flame there. So, flame will be creating very large amount of heat. Okay. Heat energy. So, large amount of heat will be generating, and that will be melting the base metal. Okay. In that case, this electrode is not getting consumed, because this is gas. Okay. Gas will be burnt, it will be combustion will be occurring, and that will be giving melting the base metal, and both will be joined. In some cases, the electrode will not be consumed. For example, tungsten inert gas, TIG, they say, TIG, tungsten inert gas welding. Okay. So, in tungsten inert gas welding, what will they do? It will create a spark, but tungsten needs very high temperature to melt. So, the electrode will not be consumed, okay, but normal electrode will be consumed. So, in that case, tungsten will generate heat, but electrode will be as it is. And why inert gas is there? Inert gas, actually, when two metals are melting at very high temperature, it is possible that oxygen will be reacting with them and corrosion will be occurring. Okay. So, that they will be shielding, that whole area will be shielded by inert gas. So, you give lots of inert gas surrounding, so that oxygen will not come nearby, and welding will be proper. Even electric arc welding also, you have to shield with some inert gas, actually. Okay. So, nitrogen also you can give, okay. Helium you can give, argon you can give. Okay. Helium, argon normally you can use for shielding purpose. Welding is happening, so that area oxygen should not be coming. So, you give lots of argon gas, so that oxygen you are removing from that area. Okay. When it is solidifying, oxygen not there, solidified, after that oxygen coming, there is no issue. But when it is very hot, that time oxygen will be reacting quickly. Okay. For that is why this inert gas will be coming up. Fine. And there are different types of joining method. One is like butt welding. So, two metal like this, one is here, another is here, and this area filled with filler material. Okay. So, this is called butt welding. So, two metals are joining, metal sheets are getting joined. Okay. So, this is called, okay, and there will be T joint. T joint is looking like this. You take one metal, another metal vertically, sometime you have to join. This is called T joint. If you make like this, T, okay, and you fill this material both side. So, you see this figure, this side you fill with material. So, you are filling and melting also. So, both metal will get fused together. Okay. So, this is called T joint, T E. Okay. And there will be corner joint. Corner joint is like this. I have one metal and I have another metal. Okay. So, this area you are giving filler material. Okay. So, both will be melted plus extra filler material also you are giving. So, that support it will get extra support. This is called corner joint. Okay. Another called edge joint. Edge joint means take two metal, okay, two metal you are joining edges. Okay. So, this is edge joint. This area will be welded. So, edge joint. EDGE, edge joint. Okay. So, there are butt welding, T-joining, corner, edge, many other types of joining also possible, and you are covering with inert gas just to avoid oxygen. Okay. Other gas are coming, nitrogen coming, there is no issue, but oxygen is a problem because it will create oxide. Okay. At high temperature reaction rate will be very high. So, you have to avoid that one. So, you have inert arc welding. So, you are creating electric spark, you have gas welding. Okay. Some other terms also used when you are joining two metals. Okay. This is called metal joining process. Okay. This is metal joining process. This is called metal joining process, wooden riveted, bolted, welded. Okay. These are metal joining process. Okay. So, another joining process is there, brazing, soldering. Okay. So, these two actually they are not base metal will not get melted, like you are sticking together. Okay. So, for high pressure application, for example, your field application, brazing and soldering will not work. Brazing means you are giving some softer material, bronze, and you are trying to stick together, like Fevikwik or some gum you are putting in paper and you are joining together, okay, two papers. So, in that case paper is not getting melted, just your surface property will be used and both will be attached. Okay. Soldering, like electric people will be doing soldering, right. So, in that case also filler material will be melted, but base metal melting not required. Two electric where they will be joining, right, that electric people. So, in that case filler material one rod will be there, that will be melting, but your wares are not getting melted. Okay. So, so those two things will not be used for your high pressure application or field big tank design. Okay. Not used for your high pressure tank joining process. Okay. High pressure or high volume. Okay. But for a specific other purpose for electric cable joining use for your field application. So, there you can use soldering, brazing or other material also fine, other joining process also fine. Some other process like the seam or welding, like joining, one sheet metal is there, another sheet metal is there, make like this, that also one joining process actually. So, there are very thin sheet, they can use that sort of technique. Another technique is there, spot welding. Spot welding also there, one option. In spot welding, what do they do? Two metals are there and use very high amount of heat, no filler material, anything. So, small amount area will be melted here, small things will be melted, like to ice cream, you press, joint, release it. Okay. So, that way it will be joining, very high temperature and pressure, maybe some small area, spot area will be temperature will be very high, melted, joined, reduced temperature, done. Okay. That also you cannot use actually, that is only surface some metal you are melting and you are using for welding purpose. So, that also you should not use for very high pressure application. Okay. So, welding, proper welding if you are doing, so that can be used for your high pressure application. So, if you want to make permanent very high pressure application, welding is better than riveting, then your nut bolt thing. Okay. And a very lower pressure application, low volume application, then wooden or some other also okay. So, welding is a fabrication process that joins metals using high heat to melt the parts together and allowing them to cool, causing fusion. So, metal will get fused. It is not brazing or soldering. So, brazing or soldering done at lower temperature than welding temperature. because when you are doing welding, temperature must be very high, 800 or something. Okay. And brazing and soldering do not allow melting base metal. Okay. The metals you are joining, this should not get melted in brazing and soldering, but spot welding melting possible, but normally strength will be lower than your actual welding process, arc welding or gas welding or TIG welding, TIG also arc welding. Welded tank. So, gas tungsten arc welding I already told. Okay. So, in that case tungsten and inert gas, argon and helium, normally it will be used. Okay. So, non consumable tungsten electrode here I am saying. Okay. So, tungsten is not getting melted. So, to iron you are melting, but tungsten you are also infusing, not possible. So, tungsten is very high temperature to melt. So, in using during arc welding process, tungsten will not get melted because of this high temperature, but base metal will be melted. Okay. So, welded advantage is that strong and durable. Welded tank have good structural integrity, less prone to leak and corrosion. So, for high pressure field application they are using. Okay. But it is expensive, because very high tank you are manufacturing and welding very large tank is very much expensive, very high skill required actually. Okay. And riveted tank less frequently used. Okay, because you got welded tank very high strength and high capacity thing. So, riveted tank people are using less. Okay. It will be simpler to construct, because just put rivet and put hammering or something and then you make a rivet. Okay. So, leakage and corrosion may be issues. Welded tanks commonly used due to their superior structural integrity, durability and lower long term maintenance requirement. However, some older tanks, especially those with historical significance, may be still riveted. Okay. So, tank battery. Now, so, each tank will have some vapor space. Okay. So, vapor space, it will be sucking outside air, inside air also vapor also will go out. So, this is called breathing. Because of temperature difference and pressure difference, the breathing is possible. So, breathing sometimes can be dangerous, because it is creating combustible mixture maybe in surrounding or inside system. So, you have to handle that vapor properly. So, you allow vapor or you do not allow, you have to decide that one. Okay. So, it will give emission, vapor space breathing cause emission. So, air or vapor pressure mixture in the vapor space expands, contracts daily, and it will be interacting with ambient air, then there will be problem. Okay. There should not be any fire source nearby. If fire source is there, then you have to handle that one. Maybe you have to use fire extinguisher or specific fire handling system. Okay. So, heating and cooling, if you have, then breathing possible, and breathing means vapor will be going out, air will be sucked in, and it will be creating mixture that will give emission, and combustible mixture is also dangerous. And more volatile component means more vapor, oil vapor you will get. Okay. So, venting and flame arrestor, specially designed pressure and vacuum vent valves protect tank against overpressure or vacuum condition. Air should not enter tank mixed with hydrocarbon in the vapor space. Okay. So, gas blanketing system sometimes they use. So, inside pressure they will be maintaining little bit higher. So, with predetermined pressure. So, that is called gas blanketing system. So, that external air will not get sucked. Okay. And still you need flame arrestor, because if there is any flame source from anywhere, it should not enter your tank system. So, there should be one flame arrestor which will be controlling fire going inside the system. Okay. In tank vent piping, it protects the tank. If there is a lightning or any spark or any other fire source is there, then you should have flame arrestor, because tank is there. So, nearby vapor will be mixed with your fuel, hydrocarbon and oxygen. So, that will be combustible mixture. So, you should have flame arrestor which should not allow flame to enter into the system. Okay. So, newer designs such as fluidic seals and molecular seals used for reducing flame. So, fixed roof tanks can fail in excessive high pressure or low internal pressure. If high pressure is there or low pressure is there, again it can fail. Maintenance of pressure and vacuum vent valves and flames arrestor required. Okay. So, if you are not maintaining regularly, you are not checking, then if fire source is there, it will not handle. So, that can be dangerous. So, that you should maintain regularly. So, inspection and maintenance, those are very important part. Okay. So, let us see one flame arrestor, how they are working. So, flame arrestor, you see left side lots of flames are there, okay, and right side there is no flame. So, there is one sieve. Okay. How these sieves look like they will make small pores, long pores. So, that if left side lots of flames are there, that flame will not enter into the right side, because it is small they will be dividing small pores. Okay. So, that will not allow to transfer heat or combustible material inside the system. Okay. So, it will be absorbing heat, because heat is the okay. When you want to you get fire needs three things actually: combustible mixture, one fuel source, one oxygen, one heat or flame source. Okay. So, if you cut any of these, it is called fire triangle. I think you can remember: oxygen, heat and fuel. Okay. So, in atmosphere this wood can burn, right, this is stable. Atmospheric oxygen also there, which is not burning because temperature or heat is not there. If you give heat also, it will burn. So, this fire triangle, any arm of this triangle, if you break, then there will be no fire. Okay. If you have all together, all three, then there will be fire. So, this flame arrestor actually they will try to break this one arm. Okay. So, if they can reduce heat, this flame arrestor absorbs heat, that means it is reducing heat. So, temperature will be going down from the flame, reduce temperature below its auto ignition temperature. Auto ignition temperature means that if you raise temperature, suddenly the fuel will be burning. So, they will be reducing below that one. So, channels designed into an element absorbs heat. Okay. Because these channels are designed to absorb heat actually. Okay. Okay. So, floating roof tank, when oil 0.5 vapor pressure less than 0.5 psi to 11.1, the US environmental agencies permits floating roof system. Okay. So, floating roof means it will give less vapor, because the roof is floating with oil level. Okay. So, there will be no free space for vapor, but it is not suitable if only oil is not stabilized. So, if lots of vapor is there not stabilized, then it is not good suitable, because lots of bubbles will be getting created. Okay. To provide safe efficient storage of volatile oil with minimum vapor loss, internal floating roof tank IFRT uses an internal floating roof, eliminates natural ventilation of the tank vapor space. Okay. So, and there are another type closed floating roof also there. So, closed floating means one internal floating plus one top roof will be there. So, the closed floating roof tank similar to an IFRT internal floating roof. So, CFRT is equipped with pressure vacuum or PV vent system, gas blanketing system used with fixed roof. Emissions from CFRT same as IFRT. Okay. So, there are different pros and cons for every system. So, you have when you are preparing for exam, so you should look at those things. Okay. And you can see two figure I have copied from two Wikimedia common source, and this is largest storage tank system. So, you can look at this figure and you can see how these systems are fixed, like bottom there will be some entry point, top will be entry point, bottom will be exit point, there will be floating system, there will be metering system, how much fluid is there. So, that measuring system will be fitted together. So, whenever people are constructing the tank system, they will be fitting all together, but when we are operating also, you should know all the systems. Okay. Yeah. So, tank battery means many time one tank will not be sufficient. So, you need multiple tanks. Okay. So, a group of tank connected receives crude oil from well, also called battery or tank battery. Okay. In battery, oil volume is measured and tested before pumping into pipeline. A typical battery, 2 or more tanks usually has capacity equal to 4 days production. The tank should be level with each other. So, and spacing about 3 feet between them. Okay. and tanks can be there in a dike. Dike means like pond like structure. So, if there is any leakage anything, so fluid will not be spilled out everywhere. So, it will be placed inside a dike. So, pipe connection located below the thief hatch, minimum 12 inch above the tank bottom. So, tank bottom is there and 12 inch above you will have the pipe connection. Inlet connection is the top deck. So, from top there will be inlet actually, from bottom you are taking out fluid. So, drain connection immediately above the tank bottom, and normally tank will be designed for 30 to 50 years. Okay. You can see this one picture of tank battery, like these are pipe connections, okay, to pipeline outlet, and these are the entry fill in pipe, filling here, filling here, filling. So, 3 tanks are there. So, filling from top, okay, and taking out from bottom to the pipeline outlet. Okay. So, this way they are designing tank battery. Okay. So, if you have iron sulphide H2S, then FES also one important part. So, that tank design requires special attention, because it is H2S and FES, all this corrosive material will be there and contaminant will be there. So, you have to select proper material, so that there will be no leakage, because H2S already dangerous to environment and human life. Okay. FES deposit keep corrosion and can go unnoticed. H2S is poisonous. Okay. We have already discussed certain amount of H2S can give death also, instant death. Okay. So, it is poisonous. So, all tanks opening should be closed. Valves permit sampling on the ground without the tank being opened. Okay. Small amount of sweet gas may be fed into the top of the tank to establish gas sweep. Okay. So, that H2S should not go out of the tank. Okay. And positive pressure is maintained to avoid air entry to reduce corrosion. Okay. So, if oxygen is entering, then corrosion will be increasing. So, just you have to stop air entry. So, extend the tank vent line away from the tank battery, use back pressure valve, flame arrestor, the vapor is flared, not vented. Okay. So, back pressure valve you have to use positive pressure, so that H2S should not go into atmosphere and oxygen also should not enter. It will be giving more corrosion, because your metallic tank you have, and you have already H2S corrosive system, and oxygen you are giving also, then everything will be dangerous. So, you have to take care of all the aspect if you are handling as H2S or very highly acidic gas. Okay. Thank you very much for today's lecture. Next day we will try to go for some calculations on metering, how to measure flow and how to calculate the flow rate. Okay. Thank you very much.